Two notes for chapter 5 in geometry. We're still talking about parallelograms, but now we're trying to prove that a quadrilateral is a parallelogram. So the different ways that you can do this. Four of these are the same things we had in the last section. First off, you got definition parallelogram, which means that both pairs of opposite sides are parallel if and only if it's a parallelogram, right? So that's the first thing we can use. If both opposite sides are parallel, it's a parallelogram. The other things we knew was that if both pairs of opposite sides are congruent, then it's a parallelogram. Then we talked about both pair opposite angles. It would definitely be a parallelogram, right? And then we talked about diagonals bisecting each other. So if diagonals bisect each other, if and only if it's a parallelogram. So the only new thing this section actually is a little bit different here. So this last theorem is basically talking about my parallelograms. So if I have a quadrilateral here and two things are true. First, I know that these opposite sides are parallel. But then second, I also know that those two sides are congruent. So it doesn't matter if you're told anything about anything else. If a pair of opposite sides are both parallel and congruent, then this definitely would have to be a parallelogram. Right? There's no other way around it. So when it's all said and done, if you're trying to prove that something's a parallelogram, all you need is one pair but you need that pair to be both congruent and parallel, then you would know you have a parallelogram. So again, this only works when I'm trying to prove that something's a parallelogram. Otherwise, if I already knew it was a parallelogram, this would be useless because we know that both pairs of opposite sides would be parallel. Both pairs of opposite sides would be congruent. But if you're trying to prove that something's parallel, this is a really useful thing to know. And it works essentially because of, similar to proofs that we've already done. If I add a transversal in there that would also be congruent to itself, then I could talk about two triangles in this parallelogram that would be congruent with alternate interior angles. So once those two triangles are congruent, then you'd know that those other two sides are congruent, and automatically this is a parallelogram. So just to save you the effort in that proof, right? If you know that an opposite pair of sides is congruent but also parallel, you definitely have a parallelogram. So now we have some examples over here. Now your notes have a few extra marks that I might have to add in here to this picture, but on this first example, the marks look like this, and that means that both pairs of opposite sides are congruent. So yeah, this is definitely a parallelogram, and you'd say opposite sides are congruent if and only if it's a parallelogram, right? The next one here has two congruent marks, but that's only one pair opposite that's congruent. I don't know that both pairs are congruent, so actually no, I do not know that this is a parallelogram. Next one has right? One extra mark that I'm missing, right? So those opposite sides are parallel, and it told you those 90-degree angles, those right angles. So this one you could actually go one of two ways, right? Yes, this is definitely a parallelogram, but it depends on how you look at it, right? If you're thinking, oh, if that's perpendicular to one side, then it's going to be perpendicular to the other side, or you're thinking about supplementary angles between those parallel parallel lines, excuse me, then obviously you'd say yes, but you'd be talking about how opposite angles are congruent if and only if it's a parallelogram, right? But you could also be thinking about this differently, and it would be faster if you thought about it this way. There is a theorem from a long time ago that said if two lines are perpendicular to a parallel line, then they are parallel to each other. But that only works if they're in the same plane. Since this is a quadrilateral, they definitely would be in the same plane. So you could say that too, right? And in that case, you'd actually just be saying definition parallelogram. Oops, got an F there. So that technically would have been a shorter proof if you were trying to show me that this was a parallelogram. So if you know some theorems, it can shortcut things. But otherwise, if you went to that opposite angles are congruent if and only if parallel, it's a parallelogram, then that's fine. It just might have taken you a step or two longer to get there. Your next one here should have some marks, right? Opposite, and then a couple of these segments inside that figure. But when I look at this, I have to understand that no, I do see that one of the diagonals was bisected, but I don't know that both of them are. No, I see one opposite pair of congruent sides, but I don't see both opposite pairs of sides are congruent. So this is no, I don't know that that's a parallelogram. So it depends. Sometimes you know, sometimes you don't. Next couple, right off the bat. Now I see two bisected diagonals. So this is definitely a yes. Diagonals bisect. Oops. If and only if it's a parallelogram. But otherwise, next one, excuse me, you have these angles that are congruent to each other. That should hint you into, right? You got a Z right here, so these two sides must be parallel. You got a Z right here, so these sides must be parallel. So this is going to be yes, definition parallelogram. Next one, 110, 70, 110, or excuse me, put the wrong number there, my bad, a 70. So I got opposite pair that's congruent. The other is 110. Now you might jump to, oh wait, that other angle has to be 110 because it has to be supplementary. But remember, we don't know that this is a parallelogram yet. You can't do that unless you knew the lines were parallel. So I have to figure out what this angle is, and I have to do it without using any theorems involving parallel lines. But that's actually something I can do, because the sum of the interior angles in a quadrilateral would be 360. So that's why this angle would definitely be a 110, right? And if I know that that angle is a 110, now I can say that this is a parallelogram because opposite angles are congruent if and only if it's a parallelogram, right? So this is definitely a yes, but I had to use that interior angle sum to get there. And then my last one here, I should have some marks to start with. Sorry, I was trying to figure out what they were. So I knew that opposite sides here were congruent, and I knew these two angles were congruent. So, fastest way to do this would be to use that new theorem that we have, that we added in today. Since I do have a z here, I also know that these two sides are parallel. So this is definitely a parallelogram because one pair, of opposite sides is both congruent and parallel if and only if, or excuse me, it's not actually an if and only if situation because I don't really need that. Right? If it's a parallelogram, right? Well, really, I should. Sorry, keep messing that up a little bit. Let me fix that real quick. I should have just said then it is, not if it is. It's a parallelogram. So anyway, those are your notes for section 2. We'll work on the worksheet in class